Let's do some vocabulary. We've talked about all this stuff already, right? So a fixed point around the figure is enlarged or reduced. What is enlarging and reduction? Dilation. That's all that fancy phrase is. This is called the center of dilation. For almost everything we do, it's going to be the origin, right? Until you hit next year, it's going to be the origin. Why? Because you're only in introduction. Next year, you're going to spend quite some time on this. And she just did it over there. So I don't know if you've seen any of the high schoolers walking around or any of your fellow eighth graders walking around with paper with hearts on it that are big and small and in different coordinates. Have you seen that paper with some of them walking around?
Nope.
Okay. So this one, the next one's a point about which the figure is rotated. Center of rotation. For us, it's going to be the origin. Had to make sure I was... The center of rotation. So far, so good?
Yeah.
A plane formed by the intersection of a horizontal number line called the x-axis and a vertical line called the y-axis. This is called a coordinate plane.
What'd you write this on?
I drew a little XY grid. A coordinate. Oh, sorry, you can't see it up there, can you? Sorry, thank you. I drew a little XY grid. Or a coordinate plane. It could be an entire aircraft made out of planes, but no, that doesn't work. Okay, a transformation that changes the size of an object. But not the shape. What did we do that changed the size? Dilation. So far, these are all pretty straightforward, aren't they? A dilation with a scale factor greater than 1. If it gets, it's called an enlargement. Most commonly, you guys are going to see 2s and 3s. And the reason you're not going to see bigger things is that would take a huge piece of paper. So if you did enlargement by a factor of 165, that would be a very large piece of paper. A figure resulting from a transformation. A figure resulting is called an image. So an image is made after you transform something. A line that a figure is flipped across to create a mirror image. When we talk mirror image, what are we talking? Reflection. This is called a line of reflection. So the next one says the original figure in transformation. If the figure from a transformation is called an image, what comes before an image? I used it a couple times. A pre-image. A pre-image comes before an image.
So that's what your camera holds, pre-images?
The pre-image in a camera, because you're actually doing a transformation, aren't you?
Yeah.
When you take a large scene, most cameras do a reduction, right, into the camera.
Yeah.
So if I take a picture of John and I'm looking on my phone, am I looking at The original,
Reduction.
I'm looking at reduction, which means John, you are the pre-image. The thing on my phone is the image. Does that make sense? That's a great question, by the way. Did that make sense? John, you are a pre-image. Congratulations. All the pictures we take of John will be images. John's upset about being a pre-image. Does that bother you that much? Okay, a dilation with a scale factor between 0 and 1. It's a reduction. Can you dilate below 0?
Yes.
No, only in the upside down if your name is L.
Who's that?
Uh-huh.
Oh. I don't watch.
You just lost points with Felicity.
And Christopher.
I don't have any of that stuff.
So, you can't reduce below 0, but you can reduce. Think about this. Wesley's designing a building. I mean, we're talking a 100-story skyscraper.
Ooh, yeah, is mine?
And he wants to build a model. How much of a reduction is his model going to be to fit in this room?
Hundreds of thousands.
You're going to reduce by a lot. Otherwise, the model's going to be stupidly large.
Like,
Well, it'd be like 200 and we could just put it back there.
So let's talk about this. A transformation of figure that flips the figure across the line. What flips a figure across the line? A reflection. One of those neat things about a reflection is the orientation changes exactly opposite. A transformation in which a figure is turned around a point. If you're turned around a point, what are you doing? You're rotating. It's a rotation. All right, the ratio used to enlarge or reduce similar figures. What did they call it up here? Scale factor. It's funny, it's already in the other answers, right? Scale factor. So I can do a scale factor of 2, which makes it twice as big. I can do a scale factor of 1/2, which makes it
half as one?
half as big,
Or half of, yeah.
right?
Somewhere like
So Felicity can make an image of herself at half scale, and then she'd have a mini-me.
that. Not really.
Felicity would have a minion at that point, and she could send her minion out to do her hard work.
Homework.
Go kick catch in the knee. All right. A change in the position or orientation of a figure. What if we call this all out? Go ahead.
Translation.
Translation is just left to right. It's a transformation.
Wait, which one did
A transformation is where you change the position or orientation. You're moving it. You're either translating it, you're either rotating it, or you're reflecting it. These are all transformations.
That's interesting.
Okay? So transformations include translations, rotations, and reflections. It's the big one because it includes all the subcategories. And the go ahead, huh?
Why not
Dilation
dilation?
is not a transformation because it does not retain its same size. So a lot of times they'll talk about it when they talk about transformations, which is why it's here, but it really is changing the size of the object. The object is no longer congruent. You get to use fancy words again. The last one, a movement or a slide of a figure along a straight line. Now that's a translation. When the bell rings, you're all going to translate right out of this room. You're going to slide out the door, right?
Yup.
But not quickly.
Very quick.
But you won't dilate. Because if you get big, you can't get out the door. If you get tiny, people will step on you. All right. Any questions on vocabulary? Hey, sit down. Any questions on vocabulary?
Why do we have computers?
Game kid.
Yeah, we ran out of time.
No.